Hey everyone, welcome back to Sumantra Codes. This is episode 11 of our series, and we are going to learn about scope and global variables and how it affects the visibility of the variables in Python. Understanding how scope works is key to writing clean, bug-free code. First, let's talk about what scope actually is. Scope refers to the area in your code where a variable is accessible. Python has 4 levels of scope: local, enclosing, global, and built-in. In local scope, variables declared inside a function and only accessible within that function. In enclosing scopes, variable in the local scope of any enclosing functions such as a nested function are accessible. In global scope, variables are declared at the top level of a script and module and accessible throughout the script. And finally, the built-in scope, variables provided by Python that are always available, like print, len, all these variable name associated with the functions. So let's start by looking at local variables. These are the variables that you define inside a function. They can be accessed from within that function and they cease to exist once the function finishes executing. Let's create an example. First, we'll create a function greet. So over here, I'm defining a local variable called Sumantra. Now I'm printing string hello name associated with the variable. This is a pretty simple basic function that we have seen earlier also. Let's call the greet function and run the application. In the output, you can see hello Sumantra. So in this example, name is a local variable within greet function. It's only accessible inside the function. And when we call greet, it prints hello Sumantra. However, let's try to print name outside the scope of the greet function. And if we run it, so it will give an error. So you see, when we are trying to print name outside the function, it raises a name error because name is not defined in the global scope. To understand it better, let's see one more example. We'll create a simple function, calculate area, where we define length as 5, width as 3, and the area is equal to length into width. And then we'll print f-string. The area is value of the variable area. Now, if we call calculate area and run it, it will give the output 15. So this function demonstrates the use of local variables. Length, width, and area are all local to the calculate area function. The function calculates and prints the area of a rectangle with these dimensions. Now let's talk about global variable. So as we have seen earlier in the definition, these are defined outside of any function and can be accessed throughout your program. To illustrate it with an example, let's create a global variable, say pi 3.14159. So over here, pi is a global variable defined outside of any scope and can be accessible by all the functions. So let's use this value of the global variable to calculate circle area given radius as a parameter. So we'll just return pi. As we know, the formula is pi into square of the radius. So we use exponentiation operator. And then if we call print calculate area with say value 5 and run it, we'll get the expected output of the area of the circle having radius 5. So this pi variable can also be accessed by any other function. For example, calculate circumference and we give the radius. Over here we know the formula for circumference is 2 into pi into radius. Now again we print calculate circumference and the radius will, let's say, 4. And we can also print the value of pi globally. So let's run it. Okay. So here pi is a global variable. It can be accessed inside the calculate circle area function without being passed as an argument. Similarly, in calculate circumference function also. This demonstrates how global variable can be used across different parts of a program. But what if we want to modify a global variable inside a function? That's where the global keywords comes in. To illustrate this, let's create a program. So we'll define a global variable counter as 0. Then we define a function increment which is going to access or modify the global variable counter. For that, we have to use Python keyword global before the counter. So this will let compiler know that you are accessing a global variable which is outside the scope of the function and you're going to modify it. Let's just increment the counter and then print the value of the counter. Counter is now the value associated with the counter. Okay. To see its effect, let's call increment twice. So we have called increment twice. As we run it, we see the counter is getting incremented by once every time the increment function is called. Let's just call it one more time to check, and yeah, it's working. If we remove global keyword from the counter and assign it to 0, then you can see every time counter is getting created locally inside the increment function and getting initialized to 0. Okay, so this example shows how to modify a global variable inside a function. The global keyword is used to indicate that counter refers to the global variable, not the local variable. Let's try one more example to understand it in a better way. Let's create a global variable balance and two function deposit and withdraw that modify the global variable balance. So here is a possible solution. We'll pass the amount to be deposited and we'll use global keyword before the balance, and then we'll increment or add amount to the balance. Call print function deposited amount new balance. Similarly, we'll create a withdraw function. We'll pass the parameter amount. Over here again global balance. So over here we should be first checking that the amount you're withdrawing is less than the available balance in your bank account, so that there should not be any negative balance in your account. So if balance is greater than or equal to amount, then only we'll deduct the amount from the balance and print with true amount new balance is balance. Else we'll say print insufficient funds. That's it. Now over here, balance is a global variable which is being accessed by both deposit and withdraw function. Let's deposit 500 to the bank account. Then let's just withdraw 200 and then again withdraw 2000. We'll run it. So we'll see when we deposited 500, the new balance is 1500. When we withdrew 200, the new balance is 1300. And when we try to withdraw the amount which is much more than the balance, we get a message that you have insufficient funds in your account. So this example showcases the practical use of global variable, and both deposit and withdraw function modify the global variable balance. Now let's tackle a more advanced concept which is called non-local variables. These come into play when you have nested functions. So let's first define a function which is nested. So we'll call the outer function as outer, and we define a variable x as local. So this x is local to the outer function. Now we'll define another function inner inside the outer function which is a nested function. Over here, if we use a non-local keyword and associate it with x, and then we'll assign x to non-local, and inside this inner function will print f string inner value of x, and then we'll call inner function inside the outer function and then print the value of x in the scope of outer function. Now let's just call outer function. We run it and we'll see that x has been modified by the inner function and the value remains same in the outer scope also. So over here, x is initially set in the outer function. By using non-local keyword inside the inner function, we modify x in the enclosing scope. The changes are reflected when we print x inside the outer function also. So the non-local keyword allows you to modify a variable in the nearest enclosing scope that isn't a global. To understand it in a more better way, let's create a function that acts as a counter using non-local variable to keep the track of the count. So we'll define create counter. We'll define count local to the create counter function, and inside this create counter function we are again defining a nested increment function which uses non-local keyword before count, and then will increment the count and return count. Now over here we are calling return increment. Now let's just create a counter variable with create counter function, and let's try to print by calling counter function twice and thrice. Okay, now we run it and we see counter is getting incremented. So the count is getting incremented. So this is an example of closure. The increment function closes over the count variable from its enclosing scope. The non-local keywords allow increment function to modify the count variable defined and declared in the enclosing scope. So finally, to make the foundation of the scope of variable more solid, let's understand the LEGB rule by an example. We'll define x first as global, and then create a function outer in which we define x as outer local. Then we'll define a nested inner function where we define x as inner local, and over here in inner function we'll print the value of inner x, and then we'll call the inner function. Now we are inside the outer function and we'll print string the outer value of x, then our function ends. And now if we print the global value of x and then call outer function and then again print the global value of x and run it. So we'll see the first we are printing the global value of x, then inside inner function we are getting the inner local value of x, in the outer function we are getting the outer value, and finally we are getting the global value outside the function when we again print the global value. So this example demonstrates LEGB, which stands for local enclosing global built-in rule. Each function creates its own local variable x which takes precedence over the outer scope. The global x remain unchanged throughout. So Python first look for variables in the local scope, then enclosing, then global, and finally built-in. And there you have it. We have covered local, global, and non-local variables and how a scope affects their visibility and usage. Remember, local variables are confined to their functions. Global variables can be accessed throughout your program. Use the global keyword to modify global variables inside functions, and use non-local keywords for variable in enclosing but not global scopes. Practice these concepts and you will be writing cleaner, more efficient Python code in no time. In the next episode, we'll learn about Python modules and packages. If you found this helpful, don't forget to like and subscribe to Sumant Codes for more Python tutorials. Drop any questions in comments below. Happy coding!